Okay, guys, I have signed on to Mr. C, so you have to go to Google Meets and then sign on using that password again. I will be changing that periodically. Page 58. Let's say a prayer together. Father, Son, Holy Spirit. I'm going to ask you guys to pray for my friend's mom that just passed away, and him and his family as well. Pray, glory be to the Father, and to the Son, and to the Holy Spirit, as it was in the beginning, is now, and ever shall be, world without end. Okay, so I'll go over page 58 for you. Then I'll go over a little summary, a little bit more to add to what cover for the test. Okay. So in 6A, it says what kind of motion does this graph represent? A graph that looks like this. This is the part where you have to start paying attention to. It says position. I'll just put D. You have to start paying attention, take your time, and pay attention to what's plotted on the y-axis. In this case, it's D versus T. So what does this line represent? There's different ways of saying it. You could say, first of all, it's Mr. C, right? Go on to Google Meet, and then don't use the link, because the links, I can't do that anymore. I've been told. So. I have to always give you a password at the beginning. Mr. C, no period, just lowercase Mr. C. No space, just MRC. Everyone got it? No? People are coming on. Good. I'll give you 30 seconds. This is the way we're going to have to do it. I'll have to give you a password at the beginning of class. You have to start with. Yeah, it's mandated. I cannot stream from the link anymore because someone at home could gain access. I'm not supposed to be streaming live. In the sense that someone at home could link into it. That's why I know it's a little convoluted, but we have to do it this way. Okay. So number 6. Yep. Sure. So I mentioned earlier, you've got to pay attention to what you're plotting on the y-axis. Take your time to see whatever is mentioned or stated. In this case, it says position. Says position. It's a position versus time graph. So that's important because that tells you you're ready. Okay. So second time, guys. Are we ready? Okay. So we have position plot along the y-axis. That tells us what's changing with time. So in this case, as time increases, position is increasing. So we can say position is increasing. With time. Okay. Some of you could have jumped ahead, skipped ahead, and said, well, the slope is a constant, so it's constant speed or velocity. That's fine. It's a little bit repetitive when we come to part B. So part B says, what does the slope represent? So the slope is constant. And equals the velocity. The value of the slope equals the velocity. So in this particular case, the slope represents positive velocity. Positive, constant velocity. Positive, constant velocity. 7. Use the intervals marked on the graph in the second graph to describe the velocity for each section. So I'm not going to draw the whole graph, but I'll just remind you. I'm going to call this point. It starts here at the origin. I'm going to call this point here my A. That's going to be my B here. That point is my B. Okay, and then it's come on. Get a little more clear. So this second point here is my B. Okay. So starting with that as my point A, I would say again, I'm flexible. You're going to use three characteristics to describe this graph. This is the sort of graph you can expect on the test, something similar. So there's three characteristics in no particular order. Is it constant or not? Well, if it's a straight line, it's constant. Constant speed or velocity. Is it fast, medium, or slow? Again, that's a relative thing. If you said slower or medium, it's obviously slower, less of a slope than BC. So I would say medium is acceptable. And it's positive. So those are the three characteristics. Constant or not. Is it slow, medium, fast? Now the third characteristic is it positive or negative? Okay, so that was for AB. For BC, for that segment there, it's constant because it's a straight line. It's moving a little faster if you said fast, great, and it's positive. And then from I would say, it's kind of hard to judge from here, but from C to D, it's a little bit lesser of a slope. So you could again say slower, constant, positive. And in D, you can see it's a horizontal line. So that horizontal line, it's important again that you distinguish what type of graph it is. It's a position time graph. So a horizontal line in this case means at rest. As long as the position time graph, it means at rest. Okay. Another way of saying the same thing is constant position. So you could say either. Horizontal line on a position time graph means it's not moving. Slope is zero. Velocity is zero at rest. Here's where we get into the negative slopes. From E to F. I would say, again, it's constant because it's a line. I would say slower to medium velocity, and it's negative. Negative velocity means you're headed west. You've turned around. Okay. Next segment is from F to G. So you can see that it's the same in most respects. Constant. It is, I would say, in this case, what's different about it is it's moving faster. And it's still moving west. You're still moving back towards where you started from, with a negative velocity. And then between G and H, you're still headed same direction, negative, still constant. But it's less of a slope, so you're moving more slowly, so slower velocity. Constant, slow, negative, or west. And you can say either. You can say on a test, I'm a little more forgiving. When you're doing like in a homework assignment, mention both. Mention both negative and west. On a test, either one. I'll understand what you mean. Eight. So we went through. I'm going to go through these pretty quickly because most of you I've already talked about most of the questions. So 8A, describe the position of runner A relative to B. At the y-intercept, you can say A is ahead of B. You can say it's ahead of B, that's sufficient. You can say it's east of B, it's got a positive position. That would be even better. What's the position? I don't have units, but I would say 1, 2, 3, 4. I don't know what the value of each unit is, but let's say 4 units ahead. You can say that as well. Any of those is fine. B, which runner is faster? The one with the greater slope. So that's B. B is moving faster. What occurs at point P? They intersect. At point P, runner B meets, catches up with A, and then passes them after that. Okay, 9. Some of these are tougher, so I'll actually add the diagrams to this one. 8A, what time does one car pass the other? Let me see if I can copy this properly. Okay, so I'll draw this in. This is again not going to be overly accurate. Yeah, I got to backtrack a bit. I don't want to get. Make sure I get this right. It's important I get this slope right, otherwise. Come on. B here. Okay. So it says here, at what time does one car pass the other? So at the points where they intersect, that's where they're meeting up with each other, and one is passing the other. So in the first case where they intersect, B is going to pass A. And then in the second position where they intersect, A passes B. One and two. And what is that? What are those times? So I'm just giving you a rough estimate. So this would be about 1.5 seconds. Again, if you're a little off, that's fine. And then the next intersection would be at 8 seconds. B, which car is moving faster at 7 seconds? So at 7 seconds, you can see, I'm going to have to zero in. I'm just going to again make this up. 7 seconds is right about here. Question is, if you're going to talk about which one's moving faster at that point in time, which one has, on the graph, which one has the greater slope? Give me a line. So at this point here, and at this point here, which one has the greater slope? So you zero in, you can see the slope of line A is there. For B, it's a little more complicated because it's still curved at that point. You've got to draw a tangent. So you can see the slope of A, actually, this one here, is greater than the slope of B. So A is moving faster at 7 seconds. Okay. C, at what time do they have the same velocity? Well, go back to the graph. I would say, again, to compare the velocities, you have to draw tangents on curve B. So if you look at this, this stays constant. Slope of A is constant. That doesn't change. You're asking yourself, where's the slope of the tangent for B parallel to this one here? Again, this is an approximation, but it looks like it's about here. That's your tangent. Parallel with this one here, roughly. And that looks, again, this is going to be a little bit off, but it's probably around 3.5 seconds. Okay. D, the part that a lot of people have problems with. Okay, so just to reiterate, I went over it with most of you, but here's the key point. In simple terms, we're going to learn more about this later. On a D versus T graph, this sort of curve, this sort of curve, you compare 2 points. Find the tangents of those 2 points. Here's a tangent of B, there's a tangent of A. Oops. Compare the slope. Slope of B is greater. The slope means speed, so the speed of B is greater. It's moving faster B than A. So this means speeding up. You're looking for a place. The question is, where is speeding up? You're looking for a place on the graph that looks like this. There is no place on the graph that curves up. So it's a trick question. No place where it's speeding up. Okay. And then E. Over what time interval is car B slowing down all the time? Slowing down is indicated by this, the opposite. This is slowing down. You can prove again. I went over with most of you how you show that. That's slowing down. You have to compare tangents. Tangents at A and B. That's A. Compare the slope of the tangent at B to A. You get the same idea as you did as we did above. If we were to plot the tangent at B, compare it to the tangent at A in terms of slope. You can see the tangent at B's slope is less. That's why it's slowing down. Slope is less at B, which means the speed is less. So where on the graph do you have this curve here? So I would say at the first part of the graph, you've got a slightly straight line. So in between about, I would say about 1.5 and it straightens out somewhere around 7 seconds. So again, this is a rough approximation. Between 1.5 and 7 seconds. After 7 seconds, you can see it turns into a straight line, so it's constant speed at that point. What kind of motion does the graph below represent? So if you look at the graph below in 23A, looks like this. Okay. Now here's the confusing part. I haven't added the labels yet on the side. So yes, time obviously it's always going to be time when we're talking about our first two graphs of this unit. You have to pay close attention, as I said earlier, to what's being plotted here. It's not displacement, not position, velocity or speed. So this no longer means constant. No longer means at rest. This represents constant what? Well, what's not changing? The velocity. Because it's a different type of graph. It's a V versus T graph. Now the parallel horizontal line represents not constant position. If you go back here, what I said earlier. Okay, I didn't say earlier. I said it right here. Right here, I said constant position. This part here, this horizontal line. Constant position, another way of saying that is at rest. What's constant here? It's no longer position, it's velocity. B. What does the area under the curve represent? So what does this represent here? It's B times T, which is just B times T, just D, the displacement. If it's a positive area, it's positive displacement. If it's a negative area, it's still displacement. It's area underneath the axis, but it's a negative displacement, which means instead of heading east, you've headed west. You turned around. Moving west. Okay. And in 11, what kind of motion? This is the second graph. This graph here. It's still a velocity time graph. Except it's a curve. What's happening to the velocity? It's not like this. This is constant velocity. So it's no longer constant, not constant. So if it's not constant, it must be changing, right? So the velocity change, how's it changing? It's going from 0, I'm just putting in some numbers, going from 0 to let's say 10. It's increasing. It's accelerating. Another word for that. Increasing velocity is another word for that is accelerating. Okay. Now I'm going to go through a rundown of the test for you. I've already mentioned some things, but I'll just add a little bit to it, a little more detail. Again, your test is Wednesday. Okay. Test. So yes, you're gonna have to describe. I would go to Google Classroom and take a look at the list that I provide with you on November 2nd. Scroll to that. The first part says distance versus displacement. So remember Distance is just a matter. What I'm going to give you is a set of numbers with directions. Remember, with this, just add up the numbers. That's all you do. Just keep adding up numbers. With displacement, when I give you numbers, pay attention to the direction. So if I say the first number is east, east is positive. It's a positive number. If I mention anything about heading west, that means you're turning around and heading. It's a negative number. You're going to subtract it. Whereas with distance, you just keep adding the numbers. Irrelevant of which direction they are. That's your clue to the first one. Number two says describe the motion on D versus T graph and calculate the slope. This is similar to what we just did in number 7. So page 58. Number 7, except we didn't calculate the slope. It's similar to what we did in the handout that I gave you last day, where you had to describe the motion, calculate, or describe the motion and calculate the slope. So it's similar to number 7, page 58, except you got to also calculate the slope. So go back to that. Similar to the handout. Which handout? It looked like this. There's a D versus T graph, and I think it looked like this. Wait a minute. No, look like that. Look like that. Calculate the slope first, and then we describe the motion. So it'll be something similar to that. And then number three, find the average velocity. Average. I would say go back to. Did some exercises on that on page 53. Number 11. Definitely that'll help. Okay. I could give you a graph like that and tell you to calculate the average between different points. So it could look like that. So it could be number 11. It could be something like this. I'd go over number 11 first. 4. Instantaneous velocity. V-I-N-S-T. You'll be given a graph. It'll be simple. I have something that curves up, something that curves down. You'll be given some numbers. You'll have to draw the tangent. I'm just telling you in advance. I'm not going to surprise you with this one. This one's a little more difficult to do. So it'll either be one of those two curves. And then I'll give you some numbers. You'll be able to calculate the slope. Once you've drawn the tangent, draw it properly, you know how to do it. So it just grazes the curve at that point. Then you choose 2 points. So this will be your point that you draw the tangent at. It'll be some letter A or B. Then you choose 2 points. Once you've drawn the line, 2 points, 1 and 2, from which you can then calculate the rise and run for. Remember, this slope is going to be negative. I would be able to define it as well. Define it. You want to give an example? Give an example of what you read off the speedometer of a car. That essentially is your instantaneous speed. Okay. 5. Use V versus T. Define displacement. Now, here's the thing. It could be a positive or negative displacement. Here's what I would do to review for that. I didn't put a question like 18 on it, but 18 on page 55 will help you. I would go over number 18.
Although it's not identical to
18,
18,
I use some
some
aspects of it.
I would go
I would
over
go over
18
18
on page
on page
55.
55.
Okay.
Okay.
And then
And then
6,
six, actually,
what I
what I
label
label
6
is going to be
three
three questions.
Part
Part
6
6 is actually three questions
based
based
on
on
your
your
assignment. So if you go to
to
28 and
28,
29,
29,
okay?
okay?
So I
I
gave you
gave
a
you
set
a
of
set of
questions
questions
on those pages. I would look those over.
You've
You've got the
got
answers to them.
to them.
They're
They're
pretty straightforward. If you need any help with any of that,
that,
as far
as
as
far
the
as the
tutorial,
tutorial,
I got
I got
problem with
problem
today
with
is I've got to start off
the
the play,
play,
our
our
rehearsal.
rehearsal.
So today's not going to work.
Tomorrow
Tomorrow
will definitely work.
Coming after school. We can
We
start
can
right
start
away.
right away
Or
at
10
10
to
to
116
116
in the
the
same room.
same room.
Okay.
Okay?
Now, could
Now,
I
could
put any further questions on? I would say study well everything,
but I would zero in on page 58.
Number
Number
9.
9.
I would look
I would
that
look that
over.
over.
It will tie into this. I will add a little bit more to this question. It'll relate to number 9. Definitely look over number 9. I would go over everything, but zero in on that. Okay?
Okay?
So we're going to start a little bit. Now, what I'm
going
going
to
to
start
start next
next
is new
is
content.
new content.
It's not on the
test.
Have to move
Ahead
ahead
here.
here. It's not on the
Not on the
test.
test.
It is related to velocity time
time
graphs,
graphs,
but it's new
New
content.
content. Yeah.
Yeah. This is notes. Okay. How do I do this? I need more room, so I'm going to zero in a bit. This will actually help you. Okay, I'm going to do a comparison. This first graph is simply for comparison. We're focusing now on velocity time graphs, but I'm going to compare it to a position time graph. Whoa. I'm going to try to compare them side by side. They look similar. In that they both involve a straight line. Let's just choose 2 points. The point always closest to the origin is the initial. Point that's closest to the origin, measured along the time axis is the initial. This is final. Final is always later in time. This is your TI. This is your
This is
TF.
TF.
Sorry, I keep
Sorry, I
moving
keep
things,
moving
but
things, but
I need the
I need
space here.
space here.
This is what
This
you
is what you
ordinarily call your run.
run.
The
The
difference in
in
these
these
is your
is your
run.
run.
Which
Which
can be abbreviated. We like to abbreviate. We use shorthand notation in physics. We replace, whenever you see a final minus initial, we replace it with a triangle. Go ahead.
Go ahead.
Triangle.
Triangle.
That's your
That's
run.
your run.
Be your. I'm trying to keep this simple for you. This will be my initial position. DI.
DI.
Okay, this
Okay,
corresponds to my final position.
position.
The
The
difference between
this,
we've talked
about
about
this
is going to
is
tie
gonna
into
what you're going to see next.
DF
DF
minus
minus
DI, we can abbreviate simply with the triangle again. Same as we did with the time. Triangle, except instead of T, D.
D.
That's your
That's your
rise.
rise.
So we
So
have, we've talked about this before. Your rise over run is the slope. That's the slope of a position time graph. And we've defined this to be what we call speed. Speed with a direction or velocity. Okay. And we got even more precise. We said if it's a straight line, it's constant velocity. You'll sometimes see the word uniform, but we'll just stick with constant for now. So in this particular case, we've said this multiple times. That line represents constant velocity because it's plotted on a position time graph. Now let's change it. I'm going to just cheat a little. Don't get mad at me. I can do this. You can't. Watch what I'm going to do. I'm going to actually plot a different graph now. It's going to be a velocity time graph. I'm going to give you time to copy it because you're going to have to actually copy it down. You're going to have to change the units here. Change some of the variables. Put them in red just to highlight. Well, put them in white. It's fine. Notice what I'm changing. Everything on the vertical axis is changing. From a D to a V. Units included. The units are no longer meters. It's meters per second. I have to change these as well. Look what I'm doing. Everything or everywhere there was a D, I now changed to V. So this no longer is triangle D, triangle V. They are exactly the same, except I've changed one variable because I'm no longer plotting D. I'm plotting B versus T. They look identical as far as everything else. Okay, notice what I did here. I've taken, instead of writing VF minus BI, I've abbreviated with a triangle again. Triangle V. Anywhere there's an F minus I, replace with a triangle. Okay, so it looks similar. Big deal. Well, here's a big deal. We are no longer plotting D versus T. It's V. So the slope takes on a different meaning. The slope is now triangle V over triangle T, not D. This is the slope. I don't like that. Still the slope, but it's the slope of a V versus T. It's still representing something that's constant. I'm not going to put a letter in yet. It's still something that's constant. Because the slope is constant. Just this one represents constant. Something is constant. Slope is constant. So whatever the slope represents must be constant. What do we call this slope? We can't call it velocity because obviously the rise is change in V as opposed to change in D. We call this acceleration represented by the letter A. So this is acceleration. And it's constant because it's a constant slope. Okay. Two different formulas. Formula one, most common. Formula two, building on what we know about change in velocity. So let's rewrite these equations. I got this. When can I use this? Constant velocity. That's when I can use this equation. It's very important to know the condition. Constant velocity, that's when you use that. Which is what you're going to use on your test. That's all you're responsible for on the test. Remember on the test I said go over what I listed. I said you have to be able to rearrange for V, D, or T. I'll give you the equation. You still have to be able to rearrange for it. Second equation is the new one. This ratio is now what we call acceleration. It's equal to the triangle V over triangle T. What is acceleration? What is this? Well, the question is, what is this triangle V? The triangle V represents a change in speed or velocity. Change in speed, which has, in our case, it has a direction. Change in speed. Y divided by time. This tells you how quickly it changes its speed. When you divide something by time, it's telling you how quickly something happens. What is another way of saying change in speed? You can either increase your speed, you can speed up, or you can slow down. Example of that is speeding up. I'm not going to put in there, but slowing down would apply as well. Speeding up. What's the condition for this one? Well, we call the slope of a straight line acceleration. What type
of
slope? Well, it's a straight line, so it's a constant slope. So this is
is
the equation for constant. I'm just repeating what I said earlier. Constant acceleration. That's when you apply this equation. Not when it's constant velocity, when it's constant acceleration. I'm going to rewrite it. It actually gets a little more complicated. I put little arrows on top. What does that mean? That means it can be either positive or negative. If the triangle B is positive and negative, so is the acceleration. Takes on the same sign. Okay. Now let's. I hope you're paying attention to what I'm writing. Hope you're not chatting with someone. Because I'm in pain now. The stupid back is acting up again. Okay. So let's rewrite this. We have triangle, which represents final minus initial. So I'm just basically going from shorthand notation back to the long version. And I'm going to just simplify things. Usually our initial time is 0. So instead of writing triangle, I'm just going to put T. I want you to rearrange this. Rearrange this for VF. Don't tell me to do this. We did this before, but see if you can rearrange it. Because we need to use this equation. Sure. You can cross multiply. You can do it that way. You get A times T. What's it equal to? VF minus VI. I'm not done. I'm going to solve for my VF. Yeah, add VI to both sides. So you get AT plus VI. That's your equation. I'm just going to put the VI in front. Doesn't matter. These are just numbers. So I'll put the VI in front. This is how we usually write it. And we usually put the VF on the left side. Doesn't matter if it's on the left or right. That's our equation. It's called the first kinematic equation. It's called a kinematic equation. Okay. Under what condition can I apply that? Because we just derived it from triangle B over triangle T, which we said was applicable under which condition? Constant. Yeah, acceleration. This has to be constant. Okay. Can it take on negative values? Yeah, now we're doing physics, so it can be positive or negative, east or west. When we're plugging in numbers, we're going to use positive or negative. The math will work out if we use positive or negative. So A is, what is this equation here? I'll go in the proper order. VF is final velocity. And it has units of meters per second. And it can be positive or negative. You have to make sure you read it carefully. If you're not told what the direction is, you can assume it's positive. And then VI is initial velocity. It's got the same unit, meters per second. Yes, it's either got a positive or negative sign in front of it. Okay. Oops. And then A is
A
acceleration. And again, it's a
And again, it's
constant, acceleration.
acceleration.
And it has
And
units.
it has units.
We'll come back to
that.
in a second here.
In a
It can
second
be
here.
positive,
It can be
or
or
negative.
negative.
We're going to come
Back
back
to
to
the unit in a second.
We'll
We'll
finish
finish
with
with
time
time
here.
here.
Time. We know
Time is just
in
in
seconds.
seconds.
Okay, so we haven't finished yet.
finished
We have
yet.
to
We
find
have
the
to find the
unit,
unit
for
for
acceleration. Let's go way back here. One sec
One
here.
sec here.
Go back,
Go back
to
to
here.
here.
How do we
How
find,
do we find
the
the unit?
We look
We
at
look
the
at the
graph.
graph.
Yep.
Yep.
Yep. You have a
You have a
unit,
unit
here.
here.
That's your unit, for your rise.
rise.
And
And
I made a mistake here. This is seconds. The unit here is seconds. That's your run unit. So you
So you
have,
have,
go back to
this
this formula. You have
you
for
have
the
for
units, meters per
meters
second on top. And on the bottom, you have seconds. That's your unit. I'm not done yet. That's your unit for accelerator. It's correct, but kind of messy. I'll rewrite it over here. Make a copy of, just rewrite it. Way down here. Meters per second on top for the rise unit. That's the unit for velocity or change of velocity. Divided by seconds, that's the unit for time. You treat units the same way as you treat numbers. In other words, you can take meters per second, dividing by a number is the same thing. We're going to put this over 1. Seconds over 1. It's a trick. Dividing by a fraction is the same thing as multiplying by the reciprocal. You just flip it. So instead of s over 1, you have 1 over s. What does that leave you with? Meters on top and seconds times seconds on the bottom. You had 2 times 2, you can express, another way of expressing that is 2 squared. We're going to do the same thing with the unit. Instead of s times s, which is correct, this is the shorter way, s squared. So that is your unit for your acceleration. Go back over here. The unit is not meters per second. That's the unit for velocity. It's meters per second squared. Okay, let's look at something. Keep this in mind. This is important. I'll rewrite it. So we started with this. That is the unit. It's just a long-winded way of writing it. Let's take a look at. Let's say this was your acceleration. What does that mean? 10 meters per second. This implies every second corresponding to 1 second in the denominator. You change your speed or velocity. Let's say it's a velocity of plus 10. What is it saying? Every second you change your speed or velocity by plus 10. Plus 10 what? Meters per second. Every second you're increasing your speed by positive 10. Every second. So what does that mean in terms of, let's make up a table here. Time, velocity. At 0, you're moving 0. After 1 second, you were just told every second you're increasing your speed by 10. So after 1 second, you're now moving at 10 meters per second. What about the next second? Well, you're just told every second you're increasing by 10. So you go from 10 to 20. This is seconds. After another second, so you go from 2 to 3. How fast are you moving now? Well, you were told this is your acceleration. So you have to add another 10. Every second you're increasing your speed by 10. That's what this unit implies. Now, we don't write it as meters per second over seconds. We simply write it as positive 10 meters per second squared. But hidden in the squared is the idea that every second you're increasing your speed by whatever the number is, in this case 10. Okay. Okay, what time is it? Okay. Well, you got a test next period, next class, so it should be. You do have to do this. It's pretty quick. I'll give you the handout. 66. Give this a try. 1 to 4. You want to work ahead, you can, but that's not much. You got 10 minutes. Work on it. How many people have banned on Wednesday? Oh, we go. No, stop it. Hands up. Really? I planned it. Quiet. How about I keep it 0 to sprinter up? I'll put your hands up. Not gonna give me. 3, 4, 5, 6. Really? Up. Seriously. You're smiling. You know what I'm saying? That's bad, guys. Listen, I will move ahead with class and on Wednesday. You're gonna get your test on Tuesday, I guess. It throws you off. Does that mean it's here. Sorry. Let me get the cell. All right. Yeah, no. I've never heard of such that. Wait, you test with that. I don't know what to do. This is really irritating. I'll just go ahead with class on Wednesday. I'll work on new stuff. Happy? Yeah, new stuff. Guys, hey. No test on Wednesday. You can thank Mr. Brawler for that. It'll be Tuesday following week. I will listen. Don't miss Wednesday class as usual. I will post it on video. Yeah. Still your spot play. No, I'm thinking. You don't have to show it. Oh, guys, hey, will there be a converting unit question possibly? I don't expect anything other than using the conversion factor 2.6. So there's numbers to meter. Yeah, it's simple, right? You go kilometer per hour divide by 3.6. Multiple. Yeah, all of that. Oh my gosh, my long battery.
Actually,
Okay, guys, you still have a few minutes. I can't believe you fluked out. I can't believe it. Yeah, I know.